Hello everyone, and welcome to the video on section 1.3 of the book. It's the section on the Borda voting method. Before we dive into what the Borda method is though, I want to remind you what we did last time. Last time we set up what an election is, the different components of an election, and we discussed one method of declaring a winner. That method was the plurality method, which is the most common method in use in elections, and it's the method that our country and most other democracies currently use to decide winners of political elections. And one of the things we did at the very end last time was talk about the pros and cons of the plurality voting method. And the main pro of the plurality method is that it's very simple. You just count the number of first place votes each person gets, and then that person is declared the person with the most first place votes is declared the winner. Okay, it's simple and straightforward. However, the plurality method has many drawbacks, and I won't go through all of them again, but one of the main ones, was that the plurality method lends itself to insincere voting or indifference. So it lends itself to people either voting for somebody that they don't really want, or those people just sort of stay home, right? So as an example, think back to like the 2004 election between George W. Bush and John Kerry. In that election, Ralph Nader was a candidate, right? Suppose that he's your favorite candidate. What are you going to do? Are you going to vote for Ralph Nader? You can, right? But you know he's going to lose. There's literally no chance that Ralph Nader is going to win. So in some sense, if you vote for him, your vote is, quote, wasted, end quote, right? I suppose you can make an argument that it wasn't wasted because you got to express your opinion or whatever, but most people would say that your vote is wasted. Your opinion doesn't matter at all. So a lot of people back in 2004, if you liked Ralph Nader, what would you do? Well, you said to yourself, well, there are two candidates, George W. Bush and John Kerry. The person closest to the beliefs of Ralph Nader is John Kerry. So even though I don't really like him, I guess I'll vote for him because I like George W. Bush even less, right? So you get people doing this, or they'll just stay home and not vote at all out of indifference to to the other two candidates. And so this is a drawback of the plurality method. People do this all the time. Oh, there's this candidate I really like, but I can't really vote for him because I know he's just going to lose. It would just be wasted. And so what we'd like is a voting method that doesn't lend itself to these sorts of things. We'd like voting methods that take into account people's different preferences. So imagine that we had a method in which you could vote like this. You could say, you know, I like Ralph Nader the best, but if he's not going to win, I'd prefer Kerry next. And if Kerry's not going to win, I'd prefer this other person next, etc. You could express your opinion more fully on a ballot, and your voice would be more heard that way. And the next three methods that we're going to talk about in sections 1.3, 1.4, and 1.5 are methods that try to do that. They're methods that try to address the drawbacks of the plurality method. So that's why we're going to talk about other methods. They're more sophisticated in some senses, and they were sort of built, or they do address some of the drawbacks of the plurality method. So just recall this fact. In the plurality method, all that matters is how many first place votes you get. It does not matter how many second place votes you get or how many third place votes you get. It's totally irrelevant. The way the method worked was just we count the number of first place votes each person got. The candidate with the most of those is the winner, right? So it's straightforward, but it doesn't. The number of second, third, fourth, etc. place votes you get is irrelevant. The Borda method, on the other hand, though, does take into account how many second place votes you get, how many third place votes you get, etc. And it sets up a point system based on how many second place votes you got, how many third place votes you got, etc. So what the Borda system does is it assigns each candidate a point value. And so the candidate with the most points wins, is how it works. And here's how it assigns the point values to people. If you have an election with N candidates, you give 1 point for a last place vote, 2 points for a second to last place vote, 3 points for a third to last place vote, etc., all the way up to N points for a first place vote. So imagine you have an election with 6 candidates. That means a first place vote is worth 6 points, A second place vote is worth 5 points. A third place vote is worth 4 points, etc. So that's how you can assign a point value to the candidate. We'll just add up all the points they get from all the different votes they got, and the candidate with the most points wins. Yeah, so the person with the most points is the winner. The person with the second most points is comes in second place, etc. Okay, so let's see how this plays out in an example. Here's the example we did last time. It's the math club election. So remember what this means. 14 people liked. Nope. Okay. 14 people liked A the best, B second best, C third best, and D fourth best, right? 10 people liked C the most, B second most, D third most, and A fourth most, etc. Right? That's what that table is telling you. So if you're going to use the Borda method, what you do is you just march through each candidate and give each of them a point value based on the system I just described. So in this election, there are 4 candidates. So that means a first place vote is worth 4 points. A second place vote is worth 3 points. A third place vote is worth 4 points. Sorry, a third place vote is worth 2 points. And a fourth place vote is worth 1 point. That's how it works. So these 14 people here ranked A first choice, first place. So A gets 4 points for each of those votes. So if you're starting to keep A's score here, he has 14 people giving him 4 points each. So 14 times 4 is how many points he has right now. These 10 people ranked him last. A last place vote is worth 1 point. So he gets 10 times 1 for this column. These 8 people also ranked him last. Each of those 8 people give him 1 point. These 4 people also ranked him last. This one person back here also ranked him last. So he gets 1 point for each of those voters. So A's total is 14 times 4 for all of his first place votes, and then 10 times 1 plus 8 times 1 plus 4 times 1 plus 1 times 1 because he got last place votes from all the rest of the voters. And that totals to 79 points. So A right now has a score of 79. B, on the other hand, let's compute what his score is. He gets 14 second place votes from this first column. Each second place vote is worth 3 points. He gets 10 second place votes from the next column. He gets 8 third place votes from the middle column, 4 first place votes from the fourth column, and 1 third place vote from the last column. So each second place vote is worth 3 points. So that's why you get 3 points here for all those 14 people and then the next 10 people. A third place vote is worth 2 points, so he gets 8 times 2 total points from the third column. In the fourth column, he gets 4 points for all of those 4 first place votes, so 4 times 4. And this last person here gave him 2 points for that third place vote. So his total is 98 points. And you can do this yourself for C and D. Let me just show you the computations. Candidate C, in the first column, he got 2 points for each of those 14 people because they ranked him third place. He got 4 points for each of these 10 people because they ranked him first. 3 points for each of these 8 people because they listed him second. 2 points for each of these 4 people because they ranked him third. And 4 points from this last guy. So candidate C's total is 104 points. And similarly for candidate D. You can go through and verify that all these numbers are correct based on the table. So notice what has happened here. Candidate C has the most points with 104. Candidate B has the second most points with 98. Candidate D comes in third place with 81. And candidate A comes in last place with 79 points. So let's contrast this with what happened last time. When we were doing the plurality method, candidate A had 14 first place votes, and that was more than any other candidate. So according to the plurality method, candidate A won. But now according to the Borda method, candidate A not only doesn't win, he comes in last. According to Borda, candidate C wins with 104 points. So you can already maybe see some of the advantages of this system. If you're trying, if somebody hands you this preference table and says, Who do you think should be the winner of this election? Who most represents the voice of the people here, right? I'm not sure that I would choose candidate A because, yeah, 14 people really liked him, right? These 14 people ranked him first. But there are 23 other people, right? 10 plus 8 plus 4 plus 1 is 23. There are 23 other people that ranked him last. They ranked him as their fourth choice. So if you just gave me this preference table and said, who do you think should be the winner, I don't know that I would choose candidate A because so many people dislike him so much. A majority of people rank him last. So the reason that candidate A doesn't win this overall election according to Borda is because Borda takes into account the rankings beyond first place. A got so few points from this chunk here. Look, in this chunk of point computation here, he only gets times 1 every time because he only gets 1 point for each of those votes. That's why his total score comes out so low. So yeah, it looks to me that C is actually maybe a better representative of the people's voice than A is. C gets 11 first place votes, which is only 3 fewer than A. He got 14. And nobody ranked C last, right? Nobody hated C the way that these 23 people hate A. Okay, so that's an advantage of Borda. Your full opinion is expressed more fully in Borda. Yeah, so here's the final ranking. C, B, D, A is how this election comes out. We don't use the Borda method at all in our political elections here, but it does come up in all sorts of other places. In particular, the way that William Jewell College votes on committee members is using Borda, if you care about that. So when I go to faculty meetings, I fill out a preference ballot, and the winner is calculated using the Borda method. Here's another example that uses Borda. It's the Heisman Trophy voting. The Heisman Trophy voting uses only a truncated preference ballot, though, so you just rank your top 3 candidates. It would be a huge pain to list all of the college football players and rank them, right? So each voter just submits his top 3, and here's how the voting came out in 2010. So 405 people ranked Robert Griffin III first, and he got 3 points for each of those votes. 168 people voted Robert Griffin III second, and he got 2 points for each of those votes. And 136 people voted him third, ranked him third, and he got 1 point for each. So his point total was 1687 if you just add across here. Well, if you do 405 times 3 plus 168 times 2 plus 136 times 1, you get 1687. Andrew Luck came in second. He got 240 first place votes, and each of those was worth 3 points. He got 250 second place votes. Each of those was worth 2 points. 166 third place votes, and each was worth 1 point. So if you want to compute his score, you do 247 times 3 plus 250 times 2 plus 166 times 1, and you get 1407. Okay, but here's an example of Borda in the real world. This is how the Heisman Trophy is awarded. Okay, there are many variations of the Borda count, and I'll just show you one of them right now. Yeah, so the main variation of Borda count is just to vary the amount of points each things are worth. So imagine a 3-candidate election in which you award, instead of 3 points for a first place vote, you award 5 points for a first place vote, and you give 3 points for a second place vote and 1 point for a third place vote, right? I mean, you could just vary the points all over the place and get a different system. And the Cy Young Award is an example of this. In the Cy Young Award, they submit a truncated preference ballot, just like with the Heisman, with first, second, third, fourth, and fifth choice. So your preference ballot has a list of 5 people on it. But instead of first place being worth 5 points, which is what it would be under normal Borda count, first place is now worth 7 points. Second place, though, is worth 4 points. That's what it would be under normal Borda. Third place is worth 3 points. 2 points, second, what am I saying here? Fourth place is worth 2 points, and last place is worth 1 point. So the Cy Young Award is essentially the same as Borda count, except a first place vote is worth more than it normally would be. So If you want to weigh first place votes more than a normal Borda, you just increase the number of points that a first place vote gets. So here's let's see, what year is this? Well, it doesn't even say. Okay. Well, whatever year Roy Halladay won, this is like 2007, I don't know. Here's what the ballots looked like then. He got 32 first place votes, and instead of being worth 5 points each, excuse me, they were worth 7 points each. So he actually got a total of 224, which is 32 times 7, not 32 times 5. But just here's an example of a modified Borda count being used in real life, the Cy Young. So in conclusion, let's list some pros and cons of the Borda count method, just like we did with the plurality method. There are several cons. First and foremost being, it's not as simple as the plurality method. The plurality method barely involved any math, right? You just had to count. The Borda count method, you now have to assign points using a fairly complicated, I suppose, point system. So it's more complicated. It's not as simple. And of course, it's not as easy to understand as the plurality method. The plurality method is the easiest to understand method that we will study. And there are some other drawbacks that we'll see in section 1.6. So there are some drawbacks to this method. But pros, well, it allows you to express your full opinion, right? So imagine this voter back in 2004 who really wants Ralph Nader to win. If they rank him first, they know they're going to give him 5 points, 10 points, whatever the point value is for a first place vote. But if he loses, they can rank John Kerry second, and then John Kerry will get 9 points or 4 points or whatever the second place vote gets, right? So by taking into account second, third, fourth place votes, each voter's individual opinion is heard more fully. And as we've seen in this video, although not always, this method will many times choose a winner that is a more accurate representation of the people's voice than the plurality method. We saw that with that math club election, right? It's really hard to argue that candidate A, let's go back, that candidate A was an accurate representation of the people's voice, as we discussed, right? He got some first place votes, but he got a majority of last place votes. More than half the people hated him. So it's hard to argue that A is an accurate representation of what the people want. And the Borda count winner reflected that. The Borda count did not choose candidate A. And there's some other pros you can talk about. I don't know if this is true or not, but if we use this method in the U.S., we might not even need the obnoxious primary system we have where candidates start duking it out 3 years before the election, right? If we were allowed to use a preference ballot and a point system, why have a primary system, right? Why does the Republican Party need to nominate a single candidate if people can just rank who they like, right? So anyway, something to think about, and that's all I had to say about the Borda method.